Hey, welcome. You're listening again to the Debugging Dan podcast. I'm Dan. Today, I'd like to talk about AI agents and a specific type of agents. So, in my cursor IDE, I have an agent, for example, that I send messages to, and then it acts, and then it sends me the results. That's an AI agent, but that's not the type of agent that I'd like to talk about today. Because what I've been working on or looking at for fun is standalone agents. So those are agents that get some input, they go to work, they do it themselves, they don't need any external guidance, and they just make stuff work. And I've been encountering some challenges there. So what I've been looking at is some kind of orchestration platform, and there are different types of orchestration platforms already there. Open source projects, paid projects, but I wanted to look into building something like that for myself to encounter and see what kind of challenges you encounter there. And there are indeed some challenges there. So the general premise is that there is a first type of agent, a conductor that has some prompt and it gets some input for that prompt, like, for example, get today's headlines, summarize them, and send them to me via email. That composer will break down the task into different subtasks. Like get the news from NBC, for example, make sure that it's summarized, and then send it off to email. And the idea is that that specific agent doesn't simply do tool calling towards an LLM API, but that it organizes the work and it sends it off to sub agents that will do the work for them, and that will return the result, and the composer will then make sure that the work gets further executed into the next step. And the advantage there is that it's possible to parallelize some work. So that means that, for example, if there are multiple news sources that need to be queried, the composer can already start several sub-agents, each for a different news source. The work gets retrieved in parallel, or the news gets retrieved in parallel. And so the execution will be faster. And another advantage is that by using sub-agents, is that you keep the context of the composer agent, so to keep that smaller. So the sub-agents might retrieve a lot of data. They need it in their context. They use the data, and eventually they get to a result. The composer only gets that result back, for example. So all the other stuff, command output and other things, that doesn't get into the context of the composer, so that remains clean, faster. And that's important for bigger tasks, because if your context gets full, you need to summarize or compress the context, taking all this information. So it's essential to keep that context of the composer, to keep that good. So that's what I've been looking into. And I found three things so far important. So one of the important elements, it's kind of obvious, but it's prompting. So I've been using some models, and as the example, I asked the composer to execute a or query or tell a different sub-agent to just do a simple echo of the response. What I found that initially I started just with a simple prompt saying, hey, you're a you're an agent and you have these tools, you can query a list of agents, determine which agent from the list you need to execute the plan based on the task that they give you. And I found that maybe it was the model that I was using, but I'll get into it later. I found that the composer model that I used was really chatty, so it was really emphasizing and giving a lot of text on, hey, I'm going to do this, I'm going to query a list of agents. Hey, I found nothing, I'm going to do another query. Hey, I didn't find the agent, I can do the task myself. So the output was really filling up. And the same goes when it eventually queried the sub-agent. It was the same result. So the sub-agent said, hey, I'm being asked to echo something. And then it gave some more verbal information. And sometimes it gave the echo and sometimes it even didn't give the echo. Just said couldn't comply or something like that. I found that being really strict, being really to the point with your prompts, telling it you just need to return the result. And I've already been experimenting with structured output. So telling the agent that it needs to output a specific JSON with a result string, for example, should help bring the agent more in line. And the part that I want to get into now is the models. So what I've been doing the tests with were local models. So I had a llama running on my local computer that had I believe it's I had one of the smaller models, like 20 billion parameters, 5.3 for Microsoft 5.4. I had that running. And I already knew from experience that those smaller models have some difficulties with instruction following. That's because they're not as big as, the other models, the commercial models, for example, that have like billions and billions, more than hundreds of billions parameters. But I figured I give them an instruction and they should, or something simple like an echo, they should be able to follow that. But unfortunately not. So I'm now also looking into using commercial models, even though there are some downsides there. And for simpler agents, I use the mini models, smaller models, for example, collider ones, while the composer then gets a beefier model because it needs to be more intelligent to tie it all together. The disadvantages of using commercial models, of course, are money, but also privacy. So when I'm using a local model, I mean, all the data they input, data it retrieves, that doesn't leave my system. And with a commercial model, obviously it does. And they promise that everything that goes via the API is not trained on, but there is a 30-day retention, for example, and you don't know what they do with the data. So I always prefer, when doing private stuff with sensitive data. And that's for everyone using LLMs, it's a good practice to not send those to the commercial models, like from OpenAI or Google or something. So that was prompting. I've already talked a bit about the models. And what I also found important during the test that I did with this platform that I was trying to build was traceability. So I was using Bun to bundle things easily, efficiently. I hadn't used Bun before, but it was pretty okay. You just pointed to an index.ts file. And for the web part, I built a React application. I just told it to serve an index.html file and then takes care of bundling all the React stuff. So that's very powerful. It also has WebSocket support built in. And I found that important to be able to show in a web UI, to show the progress and the things that were happening, streaming in the LLM responses. So initially I started with a conversational approach, just telling the bot to do something via conversation, have it return the output via a conversation, just a reply message. And I gave it some tool calling capabilities, creating a list of agents, things like that. So that's what I did. And I got some results from that. And I was able to see in real time the message streaming in via the WebSocket. But the conversation-based approach is what I knew. So that's pretty easy to set up, since it should be a self-supporting platform. I'm thinking of now pivoting to a task-based approach. So there will be some text field or trigger somewhere to start it, like a webhook, also in the UI for testing. Just type the assignment that needs to be completed by the composer, and then the composer will start a task. And in the web UI, the task will appear. You can see everything that happens for the task. So you can see the sub-agents being started, what they're doing, the tool callings that are in progress, the results that they are returning. And I should be able to see that real time, so you could really see what's going on there, which is very important. And even when the task has executed, we need to be able to manually verify what the agent has done. So you could also, if it went off the rails like halfway through the task, you might be able to steer it, restart the task from that point. That's the things that I've been thinking about. Yeah, the ideal situation is there that you just build enough, you give the agent enough tools, enough things to work with, so that it will be able to work on things that you even haven't pre-trained it for. So ideally, at some point, I just like to give it the URL of a pull request. I tell it to retrieve the coding practices, and it should be able to retrieve the data and see what's changed, and in parallel query the coding practices that we have, and then review it and send results back to the code management platform like Azure DevOps or GitHub, commenting, hey, this is what I found. This is the review result. In order to be able to do that, there should be sub-agents, but those sub-agents should then have access to specific tools. It could be terminal tools, it could be retrieval, it could be RAG. So being able to search in documents that are pre-indexed and use those results, but also using model context protocol, so MCP servers, and already have some pre-defined ways of querying things like using a Notion MCP, using the GitHub MCP to retrieve the data. And all that the user has to do is pre-configure that MCP so that there's a token available. And the user could also specify these function calls or the MCP are allowed, and these aren't. They could also differ per agent. And the side note that I'd of course like to make is that you can just have an AI go off and do things for you. You should keep it in check. Don't just store your access token everywhere and give access everywhere. You need to first verify that the MCP server is trustworthy and things like that. But that's with all things that you use with LLMs and AI. That's always important. One last final note I'd like to make. I've also looked into the agents that Cloud Code offers. So I was watching a video by Brian, that had been building Agents OS, which is a way to structure prompts for your IDE, for Cursor, for example, or for Cloud Code. And it showed some examples of agents doing things based on prompt instructions. And then I also found that they have a Cloud Agent SDK. And that at first sight, it got me really enthusiastic because I thought, hey, they did all the heavy lifting. That's just an SDK that I can integrate into my agent platform. And then it has all kind of agent abilities right off the bat. But it turned out it is a very powerful agent SDK. But one of the reasons that it's powerful is that it under the hood invokes Cloud Code. So you need to have Cloud Code running and available in order to be able to use those agents. And that's not my preference, but to keep it agnostic and flexible. But it is an interesting concept. And what I saw from the videos from Brian is that it was very powerful in doing things, checking, linting, if what was then handed off to sub-agents, but then inside Cloud Cursor, and the SDK allows you to do it outside Cursor or outside Cloud Code, but then under the hood it uses Cloud Code. That's kind of what I wanted to talk about related to agents. And then I'm thinking of the good word for it, but kind of doesn't really come to me. So it's not only agents, but it's those that go off and do things standalone. I think standalone is the right word to use for that kind of agents. In an ideal world, just tell it to do something and it will figure it out on its own. And even more ideal, if it then gets stuck, that it realizes that it gets stuck. And then it should halt execution. And then contact the user via Slack or via email or something else saying, hey, I've halted execution. I've run into some issues. Can you tell me what I need to do next? And as a bonus on top of that, what should be that the next time that you then execute a similar task, that it will also have learned from those manual instructions that were given. And of course, what I've been meddling up until now is a really simple proof of concept, and those kind of advanced features are really miles and miles away. I probably won't even get there with the experimenting that I've been doing. I think at some point I will be better off finding an open source or a different platform where you're able to configure those agents and all the stuff will be taken care of for you. But I think the practice of building or experimenting something with this yourself is that you encounter all the challenges head on, so that you already get a feeling of the things that are important to make it work, even while working on a different platform. You're already more prepared and less battle hardened, I guess, to work with that. So that was my take on agents. Hopefully you enjoyed the episode. Subscribe to the YouTube channel or on your favorite podcast app. And I'll see you on the next one.